I'm Tim from New Zealand Carbon Farming, now known as Nativa, and this is just a quick talk about one of the tools we've written to help us do what we do. So Nativa, we're one of the largest forest carbon companies in the world, so we do that mostly through planting trees and sequestering carbon, and our forests store 1 tonne of carbon every 10 seconds. So how do we do that, and what's the problem that we're trying to solve in this talk? So we plant trees and turn marginal farmland in the back blocks of New Zealand through pine and then transitioning to mixed native stands at the end. But we operate within a social license, obviously, so we don't want to plant trees where it's going to cause shadows on roads or get too close to our neighbours. Now that's a little bit tongue-in-cheek, but yeah, trees cause shadow, so we don't want to shadow our neighbours. There is legislation around this in the National Environment Standard for Commercial Forestry, specifically in this case, how high will trees grow when they're mature, and where will they cause shadow between 10 and 2 on the winter solstice, and will they shade paved roads, and will they shade dwellings? So if they do, what do we need to do to exclude planting? So first version of that was in QGIS Python using a pre-downloaded DEM. In this particular location at that time, it was just using the New Zealand-wide 8-metre DEM. Not amazing for this, but it was a good start. Iterate through those time slots and create shadow models from the terrain, just the raw terrain with no trees, then adding the trees at our predicted growth height, and then subtracting those two to get just the area of shadows that have been caused by our trees. So at this stage it was still indicating if there was a problem, didn't really tell us how to fix the problem in our planting plan. But version 2 updated that to basically do the same thing, but instead of having to pre-download a digital terrain model, actually grab it from the LINZ S3 bucket. So yeah, first of all, intersect where we're doing our area of interest with the Topo 50 sheets, because the LINZ, the LINZ tiles how the DEM and DSM data is stored. So intersect that and then generate a URL from that sheet number to load in those relevant sheets to the process. So here's the result. In this case, much better results from the LiDAR DEM and DSM, but essentially doing the same thing. So creating shadows from the raw terrain, creating shadows from our terrain plus our trees that we're predicting to add, and then subtracting the two. So in red, that's showing the areas of shadow that are just caused by our predicted trees, and then seeing if they intersect buildings or any paved roads. And of course, that can all be done in 3D to get a better idea. So in this case, yeah, the LINZ imagery base map and the LINZ buildings in yellow there as well. So second part, how do we actually fix it? This was the trickier part of the problem, but I thought about it from the perspective of the road or the building. So using the GRASS module, calculate where the sun is between those points, generate vertices in 3D, and then generate a geometry from those vertices from the centroids of the buildings and every vertice along the road. So that's what it looks like in terms of the buildings. You can see each time on that winter solstice, 10, 11, 12, 1 to 2, like a fan of where the sun is casting its rays, and do that for every dwelling in the scene. And then for roads, along the road, each time segment as well. And quickly working out where it intersects the planting plan. Cool, thank you very much.
Thank you.